Number 21 from page 178 says, a family of functions is a set of functions that are related to each other in some way. So we have the family of functions based on x squared plus 4x plus 3, and we have a k value, so we're going to replace k with 1, 2, and 3. And so it asks us to simplify each equation and write it in its standard form. So that's what I've done down here. So f of x is x squared plus 4x plus 3, so I'm going to multiply that by 2. So that's going to be k equals 1, k equals 2. I'm going to multiply by 2, and I'm going to get 2x squared plus 8x plus 6. And 3 times f of x, so k is equal to 3, I get 3x squared plus 12x plus 9. Now when we graph it, now it asks us to graph from 0 to 4, but I graphed it slightly differently. And I've graphed it looking like this. Okay, so we can see that the original red function is the f of x, and then when I multiplied it by 2, I get this blue function, and when I multiply it by 3, I get this green function. So we want to know how the graphs are related to each other. And to do that, they ask us to say, part C here says, describe how the graphs are related to each other. How are the y values related for the points on each graph with the same value of x? So I'm going to take a look at the x value when x is negative 2. And I get a y value of negative 1 here. So if I multiply that function by 2, so that blue function in that same x coordinate now has a value of negative 2. So I'm just going to write it in. So this was at negative 1. So the blue one now is at negative 2. And then if I multiply by 3, that same y coordinate becomes now at negative 3. So as I plug in the same x, my y values are going to change. In fact, they are expanding or moving away from the x-axis by a factor of 2 and 3. And I can actually do this for every single coordinate. And we can actually do this with a table of values. So for x equals 0, we know y equals 3. For x equals 0, for the blue function, y equals 6. So the original point was at y equals 3. The new coordinate now is at y equals 6. It's double. Okay, it's stretched away from the x-axis. Just like negative 1 went to negative 2, the 3 went to 6. And then if I have 3f of x, at x is 0, y is 9, we can see the same thing is happening. There is an expansion away from the x-axis by a factor of 3 times. So that k value essentially is expanding along the y-axis by whatever the factor that is. So it says here, predict the graph would look like if k was 4 and k was 0.5. Well, if k was 4, we would expect for k equals 4 to be expanded from the x-axis 4 times higher. So it's going to just go up like that. So it's going to be steeper. When k is equal to 0.5, every coordinate is going to be compressed by 0.5, so we're going to end up having a parabola that looks kind of like this. So that's going to go through 1.5, maybe somewhere around here, something like that. So it's going to be the original red graph, but now it's going to be squeezed by a factor of 1/2. For part E, it says for negative values of k. Now if we graph negative values of k, what's going to end up happening is we're just going to end up with the same y coordinates but all upside down. So the zeros are going to remain the same, and then we're going to have the graph go like that. Okay, so this positive 3 coordinate will go through the negative 3 coordinate here. So I should draw that a little bit more accurately. And essentially, everything is expansion and compression, or in this case, is going to be flipped across the x-axis. So everything expands or compresses to the x-axis, and the negative is going to end up flipping it. And we can see that when we test some functions in our graphing tool. If k equals 0, we're just basically multiplying by 0, and we're going to end up with a horizontal line. Okay, we're going to end up with y equals 0 times some f of x. and that's just going to be y equals 0, which is a horizontal line. Everything gets compressed to 0, and then we want to explain how the members of the family of functions are defined by f of x equals k x squared plus 4x plus 3 for all values of k related. Essentially, we've mentioned this before, the k value is going to stretch everything vertically. It's going to stretch vertically from the x-axis, or compress vertically to the x-axis, or flip across the x-axis. So that's what the k value is going to do for all these graphs. In fact, not only is it going to do for parabolas, it will do for all different functions.